we're going to put this in our journal, and this is going to be a quick review of all things new vocabulary and multiple representations. So there's a little cartoony up here talking about how they want to run the track. If you want to read that, you can. We're going to cut it right here, and this is what's going to go into our journal. So it says transform the equation D equals 1/4 L into each of the algebraic representations. If you look up here, it does tell you that D is the distance in miles and L is the number of laps. So you can also see here we talked about independent and dependent. So usually we write Y equals mx. So you can see that laps is our independent and distance is our dependent. And you can also remember X on the left is independent, Y on the right is always dependent. So based on this information, they want us to fill in this table. So for our distance, it's saying take the laps times 1/4. Well, 1 times 1/4 is just 1/4. And 1/4 times 2 we know is 1/2. Times 3 is 3/4, and times 4 is 1/2. 1/4 times 16 is going to be 4. So you can see we know that 1 lap is a 1/4 mile. So if we run 4 laps, we want to run a mile. If we run 16 laps, we run 4 miles. So we can take this and we can put it in a graph if we wanted. You do need to label your graph. Now this has all 4 quadrants, but our data is all positive. So we are only working within this first quadrant. So we're going to label independent is laps, dependent is miles, and we're going to need to use a scale. And we can count our scale for our independent variable as ones. I'm going to label every other one because it's kind of small. And that way we aren't squished. But our scale on our dependent variable, I don't think ones is going to work. Probably by 1/4 would be a better value. And again, I'm going to label every other one, 1/2, 1/2, 1 and 1/2, 2. And now we can graph it. So 1 lap was 1/4 mile, 2 laps is a half, 3 was 3/4, 4 was 1/2. Now, these other numbers are not on our graph. However, if we wanted to, we could continue and use this to make a prediction. But make sure you're labeling and you're using an appropriate scale. So, we can take this information and we can also go here to our set of points. So remember, our points are X, Y, or in this case, laps and distance. So they want you to fill in the missing coordinate based on that same equation. So if we have 6 laps, then I know that I need to do 1/4 times 6. We can cross reduce 2 and 3, 3 over 2. I would also take, because this is in distance, I would take a fraction, or I would take a decimal because it is talking about distance. And this is also a coordinate. Remember, when we write our equation, we want that rate of change to be a fraction, not a decimal, so that we can count rise over run. Here, it's a little backwards. Now they're saying if we run 12 miles, how many laps is that? Well, I can extend my fraction bar, and I'm saying laps divided by 4, because remember, if 1/4, that means we're dividing by 4. So the inverse of dividing by 4 is to multiply by 4. And I can see that 48 laps is 12 miles. So if you look up at your table, here we're multiplying by 1/4, but if we wanted to go the other way, we would divide by 4. We would multiply by 4. Dividing here, multiplying. 4 times 1 is 4. 4 times 4 is 16. So it's the inverse operation. Here, 8 laps times 1/4. 8 over 4 is 2. So we've gone 2 miles. And then if I run 24 miles, why you would want to do that, I have no idea. Maybe there's a bear chasing you. The inverse, again, is to multiply. 24 times 4 is 96 laps. You're probably going to be pretty tired after that. Our last set of vocabulary, domain and range. This was in our journal a while back, and if you recall, domain is just a fancy way of saying X, and range is a fancy way of saying Y. So this right here is the same as this, It's just written in a different way. So we said if you have your X values or your laps, you can find your Y values or your distance. So all of these numbers, we are going to multiply by 1/4, right? So 1/4 of 20, or we could say that's the same, remember, as dividing by 4. Same thing. So we would get 5, 7, 9, and 10. Now, you can do this in the calculator as a check, just so you know. So I'm going to show you that real quick. And then in class tomorrow, we'll do some more practice with this. So here is my calculator. New document always. And instead of calculator, we're actually going to make a graph on this. So I'm going to hit number 2. And we're going to put in 1/4. And I'm going to use X instead of L because this has an X here. And I can see that here, in fact, is my graph. Positive slope going through the origin. But the other nice thing that is very handy is if I hit Control T, table starts with T, it now gives me a table of this information. So I can see here 1x or 1 lap is 0.25 or 1/4, 2 is 1/2, 3 is 75 or 3/4, 4 is 1. I can go down all the way to where x is 16 and see that it's 4. I could go over here to my coordinates and I can say, okay, x is 6, 1.5. I can look for right here. I'm not going to do this one. I have to scroll way down to do that. 2. So I have 8. And then 24 is 96. Same thing over here. I could go all the way down to my 20s. 20 is 5. 28 is 7. 36 is 9, and 40 is 10. So we can use this device as a tool to double check our work. So we'll practice that tomorrow.